Is it just about acquiring knowledge? No, it's about transformation. It's about turning information into action, ideas into innovation. Here, we are going to train ourselves how to design a psychological experiment using the software OpenSesame. It is a free and open source program for creating cognitive psychology or neuroscience experiments. It is user friendly, easy to learn, and replicable environment that allows to create complicated behavioral experiments. So get ready for an immersive experience as we explore Unlocking Open Sesame, a hands-on training session for proficiency. But of course, we are not alone on this journey. Joining us today is our very, very special guest and a true expert in the field of cognitive psychology. I proudly introduce Dr. Vatsal Priyadarshi Pandey, an alumnus of BHU who completed his PhD with a fascinating thesis on memory deficits in persons with hypothyroidism, which is yet another remarkable work. Dr. Vatsal is currently working as an assistant professor at Lakshmi Bai College, Delhi University, bringing his wealth of teaching experience from other premier institutes such as Christ Delhi, Amity University, MP. In 2014, Dr. Vatsal qualified prestigious UGC NET with JRF. He also worked on a project funded by Department of Science and Technology, Government of India. His inclination towards cognitive psychology has driven him to explore the depths of human cognition, making him an inspiring figure in the academic community. His expertise and passion for the subject has left an indelible mark on both students and colleagues. Dr. Vatsal is indeed known for his generosity and delightful tapestry of humor. Sir, I got to know about you from your students, and they told me that you were so generous and you were always helping in nature. He is also resourceful and methodical. He showcases adept technical proficiency and offers assistance eagerly and readily to fellow colleagues and students. I welcome you, sir, on behalf of entire BHU PsyConnect. It's a great honor for all of us sharing your words of wisdom. With this, over to you, sir.
Okay, thank you for those kind words, Aparna. I try my best that the students get the best out of me because I don't really feel that I'm a teacher. I think that my students are my teacher. So, uh, coming to the topic of today, I would simply want to start because it's a little in-depth topic, and if you go out and look for the uh, typical tutorial that is given by the OpenSesame developers, you will find that the typical tutorial lengths for about 1 or 1.5 hour. I'm trying to do it in almost an hour or so because there are many aspects that have been sort of assumed by the developers. And I can tell you that I did not got any kind of formal training in learning about this particular software. I just got to know it by just playing around with it and experimenting with it. And so it is not that difficult if you simply follow my lead. It would be very helpful in designing your own experiments. And one of the most fascinating feature about this software is that it is free of cost. So you do not require a single penny to design this experiment. Yes, of course, it will require a bit of an effort from your part because sometimes complicated experiments, Open Sesame requires Python language coding. But in the era of AI technologies, you will find that it is not that difficult, because if you know, there are many websites available out there that can help you code. So if you ask them a list of instructions, they will simply produce a code that you can, um use that code to integrate it in your OpenSesame experiment, and you can run more complicated versions of cognitive tasks. So OpenSesame has it's been there for about more than 5 years now, and it was one of the first softwares who had used the power of online experimentation. So now, like in BHU, we have a very good lab where I did my PhD. We have a very good setup over there that tends to, has all the benchmark of any cognitive science laboratory, and you will find that all the equipments are there, and of course, you would require a certain amount of proficiency in using that, but then BHU is not a place where you cannot, where you will be having hurdles in learning. So you will find that this particular software uses a very unique way of uh, using the online assessment system. So if you use this software and use it with they have a specific tutorial as to how you can run those experiments online. You can collect data, and you can send the links to the participant, and the participant can take that experiment at their own comfort level, using any browser. So uh, this particular the newer versions of OpenSesame also allows you to take experiments on mobile phones, tablets, and any touch-based devices. So they have upgraded it to a more advanced level, and you will find this particular system is equivalent to a common software that is being used by researchers, which we know by the name ePrime. So first thing that I would like to know is that how many of you know how to operate this software, or have had given it a try to how to design an experiment in this software. If anyone has, they can reply on the chat box. Or if you don't have, it's okay. I'll we'll learn about it in a couple of more minutes. Okay, so basically, in case of OpenSesame, uh, let me. There are certain aspects of OpenSesame that we need to understand. So when you use OpenSesame, you download it from the link that I had provided, or you can just Google OpenSesame Cognitive Science, and you will find a website, cogsci.com, where you will find that the link is there. It can be run on Mac, Ubuntu, and in Windows platform. So they have all the specific instructions over there. The best way to install it is using their standalone exe file that you can download from their website, and just run that exe file and it will install in your system. Next thing is that when you open the OpenSesame experimenter builder, the software, you will find that there are certain things that are default. By default, they have been set. So there is this thing called backend. Basically, in case of backends, uh, backend basically refers to the basic engine on which the OpenSesame has been built. And the backend programs, there are like four types of programs in the backend directory of the OpenSesame, where you will find that each backend has its own pros and cons. So, like one of the first backend that you would see is the PsychoPy backend. The PsychoPy backend basically helps you present stimuli for a very specific period of time on the screen. So, when we talk about cognitive psychology experiments, we are not just talking about presentation, we are also talking about the preciseness in presentation. So, if I have to present a letter on the screen, it has to be presented in a very precise, time bound way. There should not be a delay, because it has been seen. Suppose if you are trying to say check that how quickly people can recognize words or sentences, and suppose you had a hypothesis in your study that it takes about 250 milliseconds to respond to a particular stimulus presented on the screen. Now, with help of computer software, it is more feasible for us to present things in a very precise way. The backends, the four backends that have been given over here, these four backends will help the experimenter to present stimulus for the right timing. Timing is everything in any cognitive psychology experiments. If the timing gets ruined in any cognitive psychology experiment, it will start affecting the result at the end. And what will happen is that you will not be able to understand that why this thing is happening. So in a normal cognitive psychology experiment, what we usually do is that we present a stimulus on the screen and we collect responses using keyboard, or in some cases we also use response keypads. I'm sure somebody from the cognitive science lab must have joined this event, and they must be knowing that there are keypads available. We had, I mean, long back, I can recall that when I was in that Alzheimer's study, we had to use one of the keypads to get the responses from the participant. So, uh, we basically present everything and we collect responses using either keyboard or using a keypad. Now, if we are saying that we are presenting the stimulus for 500 milliseconds, which is one half of a second, so we have to be very sure that our machine is actually calibrated enough to present that stimulus for 500 milliseconds. It should not reach to 550 or 520, because sometimes because of some problem or choosing the wrong backend for a particular type of study, we might end up presenting stimulus for say 510 milliseconds or 520 milliseconds. In that way, when you will if your research is if you are going to publish it in a peer reviewed journal, your research will be absolutely will outrightly be rejected, or you will not have reliable data, or it will affect your data altogether, and then you will go crazy that what is happening. So choosing the right backend is the best way to get the exact uh, the precision. Basically, the precision is very important. So we have the PsychoPy backend. The PsychoPy backend basically helps you in presenting stimulus where you where timing is also important. Second is experiment. This is also a time efficient backend where you want to present the stimulus for a particular specified time point. And these two backends have a stability in terms of timing. Whereas if you look at the Pygame or OS web browser, I'm going to talk about it later. But if you talk about the Pygame is used when you want to present stimulus that are very complicated in nature. Like if you are trying to present, say, a clock that will tick for some time and then disappear, then in that case you might have to use legacy because their timing can be compromised, but the precision in presenting the right stimulus should not be compromised. So in the previous two, you would require timing as to be perfect. There, presenting a simple letter is not a big task, but presenting it for a specific period of time is important. Their timing is important. So in case of psychopy and experiment, timing is more important. Whereas in case of legacy, timing is not that important. The nature of stimulus is important. So if you are presenting, say, a grid of box that will flicker on the screen for some time, then in that case you should use legacy because legacy will have a more stable presentation in comparison to psychopy and experiment, because then your experiment might crash if the stimulus is very complicated. I hope it is clear now. Shall we move forward? So backends are important. Choosing the right backend for your experiment is important. However, if you find that backend you are not able to understand basically what backends you should use, you should visit their website, and they have explained it pretty perfectly. So temporal presentation is very good, and they have given certain rule of thumbs. So in case of if you want to use you know psychopy functionality, basically time precision presentation of the stimulus, use psychopy or experiment. But if you want to use something called complicated experiments or complicated stimulus, then you should use legacy because their presentation of complicated stimulus is more important than just timing. Next is one thing that I would like to discuss is the refresh rate. Refresh rate is also a very important concept when we talk about the functionality of OpenSesame. So your computer has a refresh rate. Normally, any computer has a refresh rate of 60 hertz, which means that there are in every second there are 60 cycles of refreshing of your screen. So if you take out a video of your screen, you will find that your screen will flicker. It will be like a line moving slowly. If you take the video of your screen, that's because your the shutter speed of your mobile camera is able to catch that refresh rate, because the shutter speed of the camera is faster than the refresh rate of your screen. So that's why you are able to see those flickers going on your screen. Why refresh rate is important? Because suppose if you have a stimulus, say you are presenting a stimulus for 100 milliseconds, and then you have a mask. Basically, a mask can be referred to anything, like if you presented say a digit on the screen, it'll be visible till 1 second, and then just after 1 second there will be, say, some red color circle or a black circle will appear on the same space on which your digit was there. So what will happen is the mask will help us to, refresh our memory, working memory, particularly sensory memory, particularly. Now what happen is that if your stimulus is, suppose you are presenting it for like 1000 millisecond, and uh, your computer's refresh rate is say 100 hertz, then it is not a problem, because then if you divide the presentation time with the refresh rate, your presentation should go about your presentation will go about every 10, it will refresh every 10 milliseconds. So by the time your computer is refreshing, your stimulus is to be presented, and you will see a sort of a image tearing, what we call image tearing. इमेज जो है वो फट जाएगी। वो इसलिए, आप ऐसे समझिए इसको, मान लीजिए 2 बजे की गाड़ी है, आप घर से निकलते हैं 1:30 बजे, आपको ट्रेन पकड़ने के लिए, आपको ट्रेन स्टेशन जाने के लिए 15 मिनट लगते हैं। 15 मिनट आपको लगते हैं, आप 15 मिनट पहले पहुंच जाओगे, एंड आपके पास एक्स्ट्रा 15 मिनट रहेंगे। तो उससे होगा ये कि आप मान लीजिए आपको कुछ अगर खरीदना है रास्ते के लिए, जैसे पानी की बोतल खरीदनी है, या फिर कुछ चिप्स खरीदने हैं, तो वो आप खरीद सकते हो। इवन इफ यू वांट, यू कैन हैव अ कप ऑफ टी। बट if it takes say half an hour for you to reach the station, things could be very difficult. अगर ट्रेन दूसरे प्लेटफॉर्म पे हो तो आपकी ट्रेन छूट भी सकती है, बिकॉज अगर आप 1:30 बजे निकलोगे, you will reach about 2 and the train leaves at 2. So it is possible that you will enter the station and you will see the train leaving the platform. Something similar happens over here if you do not account the refresh rate of your monitor. होगा ये कि आपने ये इमेज प्रेजेंट की, प्रेजेंट करने के बाद 100 मिली सेकेंड के लिए आपकी स्लाइड पर वो स्क्रीन आ रही है जो भी आपने प्रेजेंट की है, एंड 1000 मिली सेकेंड में 10 बार रिफ्रेश होगा। 10 बार, 100 बार रिफ्रेश होगा, 100 टाइम्स। सो 100 टाइम्स रिफ्रेश होने का मतलब ये है कि इस तरह से कुछ कटी कटी सी इमेज आएगी, इस तरह से। एंड दिस विल क्रिएट अ प्रॉब्लम, बिकॉज अगर मान लीजिए आपने स्टिमुलस प्रेजेंट किया से डी, लेटर डी कैपिटल में, तो वो कट जाएगा। अब वो कट जाएगा तो उससे होगा ये कि इसका बहुत सारा असर पड़ सकता है पार्टिसिपेंट के ऊपर। नंबर एक, अगर अगर बाकी लेटर्स भी कट रहे हैं, बट दे आर नॉट प्रोड्यूसिंग अ मेमोरेबल इमेज इन द वर्किंग मेमोरी ऑफ अ पार्टिसिपेंट, then it will create a bias in the stimulus presentation. So you should always account for the refresh rate that we are going to that refresh rate of your monitor, that you should, because then you have to be careful of the fact that if I don't account that, I might have to face this image tearing problem in my experiment. अगर आपको अभी भी ये नहीं समझ में आया है तो मैं बस इतना बता देता हूँ, whenever you are designing an experiment, when it comes to timing, always account your refresh rate of your monitor into consideration. One way is that what the OpenSesame developers have done is that, suppose if you want to present something for about say 100 milliseconds, instead of uh, keeping the timing for 100 milliseconds, you should keep it 95 milliseconds to account that extra 5 second ka jo problem hai. So I'm going moving forward, and I'll take questions also after I'm done with this. So what we are going to do in today's session is that we are going to develop a very simple Stroop task. Uh, I hope everyone knows what's a Stroop task. Can anyone tell me what exactly Stroop task is? They can unmute themselves and they can speak, or if they wish, they can also use the chat box.
Anyone? Sir, may I?
Haha, sure.
Sir, in Stroop task, basically letters and colors are shown differently. For example, if yellow letter is shown, it will be written in red color.
Yeah, so basically, you have, thank you, Aparna. So basically, uh, you have a list of stimulus, and the font color of the stimulus is displayed on the screen in different colors. Basically, if you are shown the color, if you are shown the word red, the font in which the word red that has been written, the font color will be different. It could be yellow, it could be green, it could be black, it could be anything else. So trials where the word meaning and the color font does not matches is called the incongruent trial, and the trials in which the word meaning and the font color matches is called the congruent trial. The classic effect that we see is that usually wherever the font color and the meaning of the word does not matches, the reaction time tends to increase. So we are going to use uh, a very simple version. What we are going to do is that I'm going to take just two words, red and blue, and then we are going to switch their font color to reproduce Stroop task effect. Okay. Bear in mind, it is possible that we might not end up reproducing it, but we will get a very good idea about how to create an experiment in the Open Sesame experimental builder. What are the different components? How do we tend to design? And also, I'm also going to help in debugging the experiment. Okay. So first step that we are that now before we do that, I need to also explain certain things. So whenever we are trying to build an experiment in the OpenSesame experimental builder, there are certain variables that we need to identify basically. Uh, One thing is that we should be mindful about the design of the experiment, because design is a very important part of building an experiment. Unless and until you are not clear about the design of the experiment, it would be very difficult for you to actually translate that idea of the task into the open CSM. So open CSM requires you that you should know exactly what variables you are working with. So here basically the variables that we are going to work with is the word. Word is a variable. So if you recall, the exact definition of variable is that variable anything that varies. So when we talk about words, words also are variables in the sense that there are different kinds of words. Here we have two types of words, red and blue. Red is basically a word and blue is also a word. Similarly, we have a color variable where we are just manipulating two variables, two colors. red, blue, and red. And then we should also have a fair good of idea as to what a response key we are going to use. So step one of designing uh, an experiment in OpenSesame is that they should be we should translate all those things into variable forms. So, what variables are we going to work with, and what exactly we should work with? We should actually write it somewhere, and we should be mindful that whenever we are designing the experiment, we will be working with these variables. So, whatever idea of a task you have in your head, you just write down the variables that you are going to need in that. Don't go in terms of variables that you are going to say present in your thesis or do an analysis of. Those we can deal later on. But the variables that we are going to need should be noted down. So one of the first step, another concept related to your open OpenSesame is that you need to understand uh, certain terminology of any cognitive psychology task or neuro or behavioral task. So every task has a block, every block has a trial, and every trial has a sequence. Now here's the thing, आप इसको ऐसे याद रखिए, मेरे को ये बताइए कि आजकल कल इंडिया पाकिस्तान का मैच था, हाउ मेनी ओवर्स वर देयर, हाउ मेनी ओवर्स आर यूजुअली देयर,
50 sir for one
50
inning.
ओवर्स, एक इनिंग में 50 ओवर होते हैं, ठीक है, वेरी गुड। सो इनिंग को समझिए ब्लॉक, ट्रायल को समझिए ओवर्स, और एक ओवर में कितनी बॉल फेंकी जाती है, 6, करेक्ट। सो in any cognitive psychology task, you have a block, you have a trial, and you have a sequence. Block is, it could be your practice session, it could be your main session in which you are going to assess, and it could be anything that any kind of session. Suppose you are running an experiment or multiple days, तो वो एक एक दिन का एक ब्लॉक हो गया। मान लीजिए एक दिन में आप से 120 ट्रायल्स कर रहे हैं, तो उस केस में 120 ट्रायल्स को आपने अलग अलग ब्लॉक्स में हो सकता है डिवाइड कर रखा होगा, लाइक so broadly speaking, in any cognitive psychology task, you have a block and you have a trial and you have a sequence. ये चीज आप याद रखिए, ये एक हायरार्की होती है। हर ब्लॉक में कुछ ट्रायल्स होते हैं और हर ट्रायल में कुछ सीक्वेंस होते हैं। अब मैं आपको सीक्वेंस के बारे में पहले बताऊंगा कि क्या एग्जैक्टली होता है। सीक्वेंस इज एनीथिंग वेयर यू आर प्रेजेंटिंग something on a sequential basis. So, for instance, every cognitive psychology task starts with a fixation dot or a fixation cross. Fixation cross के बाद स्टिमुलस आता है, स्टिमुलस के बाद एक गैप आता है जिसे हम डिले कहते हैं यूजुअली, या SOA कहते हैं, या फिर फिलर कुछ कहते हैं, अलग अलग नाम है। And then again this repeats. So usually a trial consists of a fixation cross, stimulus screen, gap, and then repeat. तो अब हर ब्लॉक में नंबर ऑफ ट्रायल्स पहले से फिक्स होती हैं कि कितनी ट्रायल्स उसमें जाएंगी, ठीक है। तो और उसके बाद कभी कभार कुछ लेंदी जो एक्सपेरिमेंट्स होते हैं, जैसे आई एम प्रिटी श्योर कि आप लोगों को आपके प्रैक्टिकल में कॉग्निटिव साइंस लैब में एक बार जाके डेटा देने के लिए बोला गया होगा, इफ आई एम नॉट रॉन्ग। मेरे ख्याल से 45 मिनट का टास्क होगा वो, ऑलमोस्ट 45 से 50 मिनट का टास्क होता है। यू हैव टू प्रेस अ स्पेस बार वेन एवर यू सी अ बिगर सर्कल अगेंस्ट अ स्मॉलर सर्कल। दिस इज व्हाट द विजिलेंस टास्क हम लोग उसको बोलते थे वहाँ पे। तो उस केस में यूजुअली जो सीक्वेंस होता है उसमें ये होता है कि एक फिक्सेशन डॉट आएगा, फिर उसके बाद दो बॉक्सेस आएंगे, और बॉक्सेस को देखकर आपको बताना है कि अगर कोई बड़ा वाला बॉक्स आ रहा है तो आपको स्पेस बार दबाना है, वरना आपको कुछ नहीं करना है। यही होता था। सो देर इज अ स्टिमुलस, देर इज अ फिक्सेशन क्रॉस, स्टिमुलस, गैप एंड देन अगेन रिपीट। ये एक बड़ा सिंपल सा होता है। अलग अलग टास्क में अलग अलग तरह के सीक्वेंसेस होते हैं। हम लोग जो इस टास्क में यूज करेंगे वो मोर और लेस यही सीक्वेंस रहेगा हमारा। सो एक ब्लॉक में कई सारे ट्रायल्स होते हैं, और एक एक्सपेरिमेंटल सेशन में कई ब्लॉक्स हो सकते हैं। यूजुअली हर कॉग्निटिव साइकोलॉजी के एक्सपेरिमेंट में देर आर ऑलमोस्ट 2 ब्लॉक्स। एक प्रैक्टिस ब्लॉक होता है जिसमें हम पार्टिसिपेंट को प्रैक्टिस करवाते हैं टास्क की, और एक होता है मेन ट्रायल ब्लॉक जहां पर हम मेन असेसमेंट करते हैं। तो हर कॉग्निटिव टास्क जो है ब्लॉक और ट्रायल्स के टर्म्स में डिवाइडेड होता है। आई होप दैट इज क्लियर नाउ। नाउ लेट्स मूव टू द नेक्स्ट पार्ट। There are certain elements in OpenSesame that we usually use. These elements help us present, record, and log our responses. प्रेजेंट मतलब कि हमें प्रेजेंटेशन में वो एड करता है, ये सारे एलिमेंट्स। रिकॉर्ड मतलब इट हेल्प अस टू रिकॉर्ड द रिस्पॉन्सेज दैट वी आर गोइंग टू गेट, and log basically helps us in maintaining a logbook of all the trials and the related variables, जैसे reaction time, accuracy, and other things. So next part is I'm going to talk about step 1. तो पहला, अब मैं अपना स्क्रीन छोड़ के आपको एक्चुअल एक्सपेरिमेंट का दिखाऊंगा। I hope my screen is visible. Just a moment. I hope my screen is visible.
Yes, sir.
Okay. So आपने जब ओपन सिस्टम इंस्टॉल कर लिया है तो उसके बाद जो है आपको इस तरह का कुछ सॉफ्टवेयर खोलने के बाद इस तरह का कुछ अरेंजमेंट दिखेगा। एक कमांड लाइन चल रहा है बैकएंड पे, इसको बंद नहीं करना है, क्योंकि अगर इसको आप बंद करेंगे तो ये पूरा एक्सपेरिमेंट बंद हो जाएगा, ये विंडो भी बंद हो जाएगी, तो उसको छोड़े रखना है। नाउ if you look at OpenSesame has a very we call this the dashboard. बेसिकली ये मेन एक्सपेरिमेंट का व्यू है। यहाँ पर आपको वो सारे एलिमेंट्स दिखेंगे जिनके बारे में मैंने बात की थी। यहाँ पर आपको एक ब्रीफ आउटलाइन मिलेगी इस एरिया में, जहाँ पर आप देख सकते हो कि आपका एक्सपेरिमेंट का फ्लो क्या है। यहाँ पर आपको एक विंडो दिखेगा जिसमें करेंटली आई एम एट द वेरी स्टार्ट ऑफ द एक्सपेरिमेंट। सो द सॉफ्टवेयर इज आस्किंग विच बैकएंड आई एम गोइंग टू यूज। बेसिकली ये बैकएंड हमसे पूछने का ये स्क्रीन है। So right now I'm going to use legacy. I'm not very concerned of timing, but since it's a time critical experiment, I should use PsychoPy or experiment. However, since I'm presenting my screen on an external browser, it could affect the presentation time, so I am using legacy only. However, in case of in your case, you can use psychopy or experiment if your stimulus is not time critical. Now ये एक नॉर्मल सा डिफ़ॉल्ट सा मैसेज आता है जो ये बताता है कि एग्ज़ैक्टली आप क्या-क्या कर सकते हो एक्सपेरिमेंट्स के साथ में एंड द डेवलपर्स टेल यू दैट व्हाट ट्यूटोरियल्स इफ यू आर स्टक एट समथिंग यू कैन फाइंड आउट। दे आल्सो हैव एग्ज़ाम्पल एक्सपेरिमेंट्स, तो अगर आप टूल्स पर क्लिक करिएगा तो आपको यहाँ पे क्लिक करने के बाद आपको एग्जाम्पल एक्सपेरिमेंट्स के वेबसाइट के लिंक्स मिल जाएंगे जहां पर आप जाकर इनको डाउनलोड कर सकते हैं और चला सकते हैं। तो वी डोंट नीड दैट, सो वी आर जस्ट गोइंग टू सेलेक्ट हियर एंड प्रेस डिलीट एंड इट विल गेट डिलीटेड। अब मैं आता हूं अपनी स्लाइड पर, एक बार आपको बता दूं कि हमारा स्टेप क्या होगा। बाय द वे, I have created a Google folder and I can share the link of that. Just give me a second. Uh, Everyone can access all these uh, experiment that I have created for this session. It's available over there and the PPT also. So they can download it. So पहला जो step है वो ये है कि we have to create a practice sequence. Now this is not the same sequence that I was referring to. ये sequence जो मैं यहाँ पे कह रहा हूँ ये OpenSesame का अपना टर्मिनोलॉजी यूज हो रहा है। सो OpenSesame में अगर आपको मैं बताऊं, सीक्वेंस का एक एलिमेंट है। सीक्वेंस का एलिमेंट जो होता है वो बेसिकली आपको कोई चीजें अगर सीक्वेंस में चलानी है तो उसके लिए इसका यूज आता है। तो जहां पर भी आपको सीक्वेंस में चीजें चलानी है वहां पर आप सीक्वेंस का यूज करोगे। फिर एक होता है लूप। लूप बेसिकली एक तरह की ओपन सिस्टम की इंटरनल एक्सेल फाइल होती है। इसमें आपका जो ट्रायल है उसकी डिटेल्स लिखी होती हैं। अभी मैं बताऊंगा कि लूप का क्या काम आता है। देन कोई भी स्टिमुलस को प्रेजेंट करने के लिए यू नीड अ स्केच पैड। So in order to present visual text type of stimulus, there is a sketch pad. But if you want to say present a questionnaire, that can also be done. There is a different element for that called the form element, which you can use in OpenSesame to present questionnaire based stimulus. Currently, for OpenSesame, the best response collection items are keyboard and mouse. So keyboard and mouse are elements which you can use to collect responses if whatever responses that you want. So जैसे आप कीबोर्ड में बोल सकते हैं, प्रोग्राम कर सकते हैं एक्सपेरिमेंट को कि ए दबाएंगे अगर हम कोई एक लेटर देख रहे हैं, से एक्स देख रहे हैं तो ए दबाएंगे, और कोई लेटर पी देख रहे हैं तो हम से स्पेस बार दबाएंगे। ओके, सो response items help you collect responses from the participant if you are presenting something. The logger basically helps you in logging your all the data that is generated from the experiment. तो ओपन सिस्टम की सबसे बड़ी खासियत ये है कि it tends to record everything. You can still ask the OpenSesame software to record only few of the variables that are getting generated from the experiment. But with the help of logger, you can log everything into the logger, and the logger generates an Excel file that can be used to analyze your results later on. I'm going to tell you how once we complete the experiment building. So far, if you guys have any question, you can ask me and then we can move ahead. If you guys have any question, you can ask me.
Anyone having any question, please raise your hand.
Yeah, Deva
Hello,
Smita.
sir.
Yeah, hello.
Yes, sir. Sir, actually, I had a question from the presentation time, that thing, refresh rate.
Haha.
So actually,
Please.
I could not get it. Like, what should we do for the like refresh rate? What should it be so that there
So,
is no
yeah,
image
so
tearing?
yeah, so suppose if your monitor's refresh rate is 100 hertz, suppose, and you are presenting something in the multiple of 10, then it's okay. But if you are presenting which is not perfectly dividable by a multiple of 10, then you will have an image tearing. So you should always incorporate the refresh rate of your monitor while deciding that how much long you are going to present a stimulus on the screen. आपका रिफ्रेश रेट अगर say 100 है, if your refresh rate is 100, then for 1 second the screen will refresh itself 10 times. If you are choosing a multiple of if you are choosing a number that is not a multiple of 10, then you will have image tearing. Whatever you will be presenting, it will be presented in a tiered way. Suppose if you are presenting a face on the screen, and if you wanted to know the that how quickly people can recognize the emotion presented on the screen, so the image will get tiered. So the actual face that someone is going to see, it would be tiered apart, and it would be very difficult for a person to identify the correct emotion. Am I clear on that?
Yes, sir.
Okay.
So like you gave an example for presentation time, it is 100 milliseconds,
Hmm.
and for refresh rate, so it should be like 95 hertz
Yeah.
or like.
The refresh rate, so usually what the makers of OpenSesame, what they had done, what they have told us, and what is the normal protocol is that you should deduct 5. That way your stimulus will have extra 5 milliseconds to get extra 5 milliseconds, so there will be some gaps, and it will help in preventing us from getting the image teared on the screen. So whatever you are choosing, just deduct 5 on that. So like if we are going to present something on the screen for 1000 milliseconds, we should deduct 5, and that should be 995 milliseconds, not just 1000.
Okay, sir.
Okay,
Thank you.
thank you, thank you.
Yes, sir.
Okay, so let us move on and let us quickly prepare a practice sequence. So the practice sequence is basically a sequence where you are going to present something on the screen, and you are going to collect data, and you are also going to give the feedback to the participant कि उन्होंने सही बटन दबाया या नहीं. Okay, it involves a very complicated process. अगर ये आप समझ गए तो आप मेन ब्लॉक बहुत आसानी से बना सकते हो. So first thing is that we need to let me share my screen back to OpenSesame. So first thing that you need to do is यहाँ पर एक वेलकम मैसेज है, so you can hover your cursor over here, right click it, and you can delete whatever that has been written. Then you can, it is very similar to paint by the way. So अगर आपने पेंट यूज किया है, so वहाँ पेंट में आप ऊपर टूल्स में जाकर होम टैब में टूल्स में जाके you can select anything, any shape, anything. So similarly you have different options given over here. So I'm going to select the text option, which is denoted by a letter A. And I'm going to click over here and I'm going to write a simple uh, message. Okay. And before pressing OK, you can before that you can also change the font. So यहाँ पे OK कर दिया. अभी ये थोड़ा सा छोटा दिख रहा है. So you can, there are two ways of doing it. Let me tell you the easy way, because coding से भी हम इसको कर सकते हैं. So before selecting the area on which you want to present your text, you can increase the font size to 28. You can click bold, and then whatever that is being presented over here, it would be presented in bold. You just select welcome to Stroop task. That's it. You can have your, and then if you want to drag these, you can drag these also, this whole line. So you can select the cursor option over here, hover your cursor over the text, and simply drag it to whatever side of the screen you want to take. Let's put it in somewhere near middle. Okay. Then ये एक तरह का आप पीपीटी बना रहे हो. जैसे आप पीपीटी में इस साइड आपके स्लाइड्स होती हैं और इस साइड आपका स्लाइड, जो आप जिस स्लाइड पर होते हो उस स्लाइड के बारे में दिखाता है. इट्स जस्ट लाइक दैट. सो हियर यू हैव ऑल whatever you are working, and this basically this area shows you the flow of your experiment. Now next thing that you want to do is you can have a welcome screen, or you can have a welcome screen and instruction. So you can write your instructions over here, whatever instruction you have. अब ऐसा नहीं है कि यहाँ पर आपने एक बार टेक्स्ट भर दिया तो दूसरी बार नहीं कर सकते. You can add multiple lines of text. So you can again select area, but before you, now since you have already selected the font size and the font type, OpenSesame will remember this choice for the next line of text also. So it will not change the font size back to its default, which was 18. So you can again select over here, write your instructions, and click OK. Now moving to the next part. Remember I talked about a sequence. So यहाँ पर OpenSesame थोड़ा सा कंफ्यूजिंग होता है, तो प्लीज बी माइंडफुल ऑफ इट. सो सीक्वेंस में हमको यहाँ पर सीक्वेंस एलिमेंट को ड्रैग करना है. यहाँ से ड्रैग, इस पे आप यहाँ पर अगर कर्सर लेके जाओगे, सो यू विल सी अ हैंड. So basically here you can select whatever element you want to work with, and you can simply hover your cursor on the desired element and click the left mouse button, drag it over here. ड्रैग करने से ये वेलकम स्क्रीन के जस्ट बाद सीक्वेंस स्टार्ट होगा and you need to label it also. You can label this sequence also. So you can say practice sequence. Now remember I told you that the sequence tab, the sequence element, helps you run things in a sequential way. Okay, but every sequence requires an instruction. So next step of creating practice sequence is to tell the sequence what to run exactly. Okay, so remember I talked about the loop item. Next thing that we need to know is that we need to drag this sequence, drag this over to sequence and just release it. तो once you select, select कैसे करेंगे फिर से बता देता हूं मैं. Hover our cursor over to the loop item, click on left mouse button, drag it and just release the mouse button over there, and it will ask you ki whether you want to put this into the practice sequence or after the practice sequence is also very important. So you will select into the practice sequence. अब ये loop आ गया basically. So every experiment has a practice sequence in in OpenSesame followed by a loop. Loop क्या होता है? Basically, loop is a kind of an Excel sheet inside OpenSesame that tells OpenSesame uh, what is the sequence of the trial or information about the trial. Like in Stroop task, we have two types of trials, congruent and incongruent. So this loop item will tell the OpenSesame that which trial is a congruent trial and which trial is an incongruent trial. It also help the OpenSesame identify which stimulus to present in which trial. Abhi we are going to see how it works with the OpenSesame. Now OpenSesame has a very good way of presenting stimulus, and this is the reason why it is most preferred, because e prime में भी ये functionality है, but then e prime is a paid software and OpenSesame is not. So it has a new functionality called full factorial design. I'm not going to ask what is a factorial design because you should know by now. I mean, I think that third semester तक सब लोग आ गए हैं यहाँ पे. थर्ड सेमेस्टर में ही बीएचयू में यूजुअली फैक्टोरियल डिज़ाइन पढ़ाए जाते हैं. सो if you click on full factorial, you will find that there is a Excel sheet that is created. मेरे केस में मैंने ऑलरेडी एक एक्सपेरिमेंट बना रखा है, सो ओपन सीसम ऑलरेडी नोज it basically has extracted the options from the previous file and it has given me already, so I'm going to use it. बेसिकली मैंने बताया था आपको कि हमारे पास तीन वेरिएबल्स हैं जिन पर हम काम कर रहे हैं, कलर एंड वर्ड. सो वी आर गोइंग टू मैनिपुलेट द कलर ऑफ द वर्ड. तो वी नीड टू टेल ओपन सीसेम दैट भाई कि एक वेरिएबल जो है वो कलर नेम है, दूसरा वेरिएबल जो है वो वर्ड है. ओके, सो basically OpenSesame will generate all permutations and combinations of these two variables to produce a list of trial. Once we click OK, ये हमारे पास ट्रायल्स की लिस्ट आ गई और each row represent different aspect of the trial. So row number 1 shows a trial where the color name is red and the word is red. Second row tell us that the color name is blue and the word is red. Similarly, third, the color name is red and the word is blue, and the color name is blue and the word is blue. Anyone who has been using Superlab, कोई है यहाँ कॉग्निटिव साइंस लैब से? सो कॉग्निटिव साइंस लैब में हमारे यहाँ अभी भी सुपर लैब यूज करते हैं. रीजन बीइंग कि सुपर लैब जो है वो इट्स अ लिटिल प्रिमिटिव सॉफ्टवेयर एंड यू हैव टू manually create the list of all the permutations and combinations of all the variables to produce a list like that. तो उस केस में क्या होता है कि अगर यहाँ पर तो 2 ही वेरिएबल हैं तो 4 ट्रायल बनाने में ज़्यादा टाइम लगेगा नहीं. बट जहाँ पर आपके पास कई सारे वेरिएबल्स हैं, वहाँ आपको बहुत दिक्कत होगी. सपोज यू वांट टू क्रिएट अ एक्सपेरिमेंट विथ 120 ट्रायल्स. क्या आप 120 ट्रायल्स का कॉम्बिनेशन बना पाएंगे? नहीं बना पाएंगे ना. तो उस केस में OpenSesame का फुल फैक्टोरियल डिजाइन ऑप्शन बहुत हैंडी है. यू जस्ट टेल OpenSesame कि ये वेरिएबल है, ये उनकी वैल्यूज हैं, एंड वंस यू क्लिक ओके, बिंगो, एवरीथिंग गेट्स जनरेटेड ऑटोमेटिकली. अपने आप OpenSesame आपके हर वेरिएबल के परम्यूटेशंस एंड कॉम्बिनेशंस जनरेट कर देगा. दिस विल हेल्प यू कट शॉर्ट योर whole task in a very easy automated way. Otherwise होता ये है कि सुपर लैब में आपको पीपीटी स्लाइड की तरह सारे ट्रायल्स का सीक्वेंस स्लाइड बाय स्लाइड बनाना पड़ेगा. सो इमेजिन इफ देयर आर 120 ट्रायल्स इन एन एक्सपेरिमेंट एंड मान लीजिए 4 ब्लॉक्स हैं, तो हर ब्लॉक के 30 ट्रायल्स हो गए. आप जो बंदा बना रहा है सुपर लैब पे जो काम कर रहा है, उसको वो 30 ब्लॉक्स बना के और उसको मैप करना पड़ेगा, विच इज अ वेरी हेफ्टी टास्क. इट क्रिएट्स इट्स वेरी डिफिकल्ट एंड इट क्रिएट्स अ लॉट ऑफ ट्रबल फॉर पीपल, यू नो, if you are short of time. Any question so far? Because this is very important. इसके बाद समझना आसान है. Any questions so far? I hope everyone is following through. Also, if you guys need a break, you can take a break of 2. It's almost an hour. आधा 1 घंटा निकल गया है. If you guys have any question, you can let me know. So shall we move forward?
Yes, sir.
Okay. So next is that we need to tell OpenSesame कि भाई कौन सा बटन जो है वो किस ट्रायल के लिए इम्पोर्टेंट है. बिकॉज लूप बेसिकली houses everything that OpenSesame will work in presenting the will use it while presenting the stimulus. So ये practice loop है, इसको नेम कर देते हैं practice loop and we can say correct E as one of the variable, and we can designate for each trial what is the correct key, what would be the correct key. So यहाँ पर we can denote that what key should be pressed when the color is red. So I'm using Z as the other key and / as the other key. Why I'm using that? Because if you look at the key arrangement on a keyboard, they are this apart almost. I can use the shift button also, but then I have to type a lot in that. So इतना दूर है. यूजुअली आप जब भी एक्सपेरिमेंट बनाइए तो कोशिश करिए कि इतनी दूरी रहे दो रिस्पॉन्स कीज में, क्योंकि जल्दी जल्दी में हो सकता है पार्टिसिपेंट गलत की दबा दे. सो आई एम यूजिंग दैट. सो / and then again Z and then / Now हमने OpenSesame, we have told OpenSesame that Sesame that see these are the correct keys for each of the trial. Now we also need to know that which trial is congruent and which trial is incongruent. So we can write trial type. So we can use the coding C as for congruent, I for incongruent. So here the color name and the word is mismatched. So I'm using I. Again here the color name and the word is a mismatch. So I'm using I. Similarly, the color name and the word is same. So I'm using C. So ये आपका loop तैयार हो गया. Now loop तैयार हो गया तो इसका मतलब ये है कि now the loop knows that uh, uh, which trial is the correct one and which trial is the incorrect, which trial is the congruent one, which trial is the incongruent one, कौन सी ट्रायल में क्या रिस्पॉन्स की सही है, कौन सी ट्रायल में क्या रिस्पॉन्स की सही है. So for each trial there is a specific key that is correct. So if somebody presses that, their score will be as correct, and if they don't, they'll get a 0. So we need to have another sequence item to tell the loop that what would be the order in which or what would be the exact sequence of trial. It is very important. So practice loop basically will run the loop item basically runs things that are there in the sequence. So it needs its own sequence item. ये बहुत important point है. The loop item will need its own sequence item. So यहाँ पर we can hover our cursor to the sequence item, drag it and take it over there and insert it into a practice loop. Now this sequence item में हम लोग एक्चुअल ट्रायल का जो सीक्वेंस है वो डिजाइन करेंगे. So for that we can use the plus option over here. We can go to the append new item, and first thing that we need to show is a cross sign, and for showing any stimulus we need a sketchpad item. Then we will need another sketchpad item to show the actual stimulus. Then we need a keyboard response to collect the response, and then we need two more sketchpad items that I'm going to tell why. पहले इसकी बात करते हैं. So let's name it as fixation. Then here stimulus. Let's keep it this only. Here there will be a slide that will show that whether the person has pressed a correct response or not. So wrong, right. Now you can see there is an option given over here which says run if. रन इफ का मतलब ये होता है कि ये जो राइट और रॉन्ग वाला ये जो मैंने अलग अलग आइटम्स जो ऐड किए हैं लूप सीक्वेंस में, इनकी कोई कंडीशन है रन होने की. सपोज इफ अ पर्सन इज say pressing the wrong item, wrong button, I can ask OpenSesame to run only the wrong slide. That way, they will know that whether they responded correctly or not. Similarly, if they are pressing the correct button, the slide of right will pop up and it will show whether they are pressing the correct button or not. Okay. Now let us refine this whole sequence because we need to tell OpenSesame की fixation cross कितनी देर के लिए show करना है, stimulus कितनी देर के लिए show करना है, कीबोर्ड रिस्पॉन्स में कौन कौन से कीबोर्ड रिस्पॉन्स अलाउड हैं. So OpenSesame can bar all other keys on the keyboard and only accept when somebody presses Z and /. और कोई दूसरी की रजिस्टर ही नहीं होगी कंप्यूटर में. Okay, so these are few things that we need to do. So we will go to the fixation option and यहाँ पर duration में we will write say 495. Similarly, we want to show the uh, word for the stimulus for say 1000 milliseconds, so 995. Now, here's the part. So correct response key के लिए we have to tell OpenSesame कि कौन से ट्रायल के लिए कौन सी करेक्ट रिस्पॉन्स की एडमिसिबल है. That knowledge can OpenSesame get from the correct key variable that we have defined in the practice loop. So we will do that. And allowed keys के लिए we can say Z. And when we have to say we have to enter multiple keys, we have to separate each of the key names by semicolon. यहाँ पर भी देखिए लिखा हुआ है separate by semicolons. So /. And here in every cognitive psychology experiment there is a time bar. So we can give a response time window कि इतने विंडो के इतने टाइम के अंदर स्टिमुलस का रिस्पांस आता है तो ठीक है, नहीं तो नेक्स्ट ट्रायल में चला जाएगा. सो वी विल से 995. Now here's the thing that we are going to do. We need to show something to the participant and we can show it, say we can put it 495. So we have to show the participant something. So I have, so you can also uh, insert some images, funny images. So I have few. First, you need to upload those images in the file pool of the OpenSesame. So you have to select this add file option and so this image will pop up whenever a participant will press a correct key. Sorry, this selected the wrong image. Uh, and for right, we can select some other image. And we can again specify the duration for the presentation sign. Now, our experiment is almost ready for a practice trial, but we still need to program the exact stimulus that is going to appear on the screen. Remember, for each trial, the stimulus is different. So for some trial, we are showing the word red in red color. For some trials, we are showing the word red in blue color. So we have to program that as well in the OpenSesame. So we go to the stimulus slide, we select, and we can change the font size to 28, make it bold if you want, and just click on one of the sides and we can, इसको आप नोट कर लीजिएगा कहीं. We need to specify we need to specify OpenSesame that whenever whatever trial type we have, should be according to the configuration given in this loop sheet. So basically, OpenSesame will run this sequence: fixation, stimulus, response key, wrong, right, and in the stimulus section, it will pick up the value that is given here under word. So say if this is the trial, the word red will appear in red color. I'm going to show you how. So, and we can ask, we always do that by starting with square brackets and ending with square brackets. So when we add any text material between the two square brackets, or OpenSesame automatically understand that it's a variable that is being picked up from the loop item that is there in the practice sequence. तो ये हो गया. Then थोड़ा सा कोडिंग का इसमें एलिमेंट है, इतना नहीं है. सो जो ये आप स्लाइड देख रहे हो, ये आपको ग्राफिकल फॉर्म में दिख रही है, बट इसके पीछे एक पूरा 4-5 लाइन का कोड लिखा हुआ है और उस कोड में हम लोग थोड़ा परिवर्तन करते हैं. दैट इज द ओनली कोडिंग यू शुड नो टू रन योर एक्सपेरिमेंट्स. एंड कोडिंग की जरूरत ही नहीं है, उसमें एक्चुअली कोडिंग है नहीं बेसिकली. So we will go over there. This is the view option. Select view, view script. अब यहां पर देखिए ये जो लाइन लिखी है ना, ड्रॉ टेक्स्ट लाइन, और ये सारे फॉन्ट किस तरह का फॉन्ट होगा, किस whether the font is bold or not, what is the font size. कलर में देखिएगा वाइट लिखा हुआ है. Now, for every trial, we need to have, uh, we need to display the word in a different color, and the information for a particular trial type is already given in our sheet. तो अगर ये ट्रायल है तो वर्ड लेटर रेड और कलर नेम रेड. सो ये रेड कलर में शो होना चाहिए, and it should change according to the trial type. सो कलर में भी हम ये वाइट मिटा देंगे एंड वी विल सिंपली इंट्रोड्यूस आवर ब्रैकेट्स. We will say color exact. It would be better to copy the exact wording because then OpenSesame पागल हो जाता है and it gives you funny errors. Apply. Now, when we will run this experiment, this slide will the 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 stimulus on this slide will change according to the loop information that is given over here. Any question so far? Anyone? Any question?
If anyone has any question, please raise your hand or type in the chat box. We'll see to it.
So,
Yeah,
so would you please repeat this last step from choosing the view option?
yeah, sure. So we go to the stimulus slide. We hover our cursor over the view option given over here. Select, press left mouse button, and we get to know what we get this drop down menu, and we select view script. We simply click view script. So script view tell us everything but in scripted form. So like in script, it is written set duration 995. This means that the duration of this particular slide is 995. Description, display stimulus. So it basically varies according to the type of item that we are using. Draw a text line. It's basically telling OpenSesame in Python form that you need to draw a text line, and it tells OpenSesame what is the coordinate of that text line, what is the color of that text line, what is the font. So if the font is bold, its value is equal to yes. Font size, it's HTML and many more things. What you should know is that you in your experiment you need this text and color to vary according to the type of the trial. So like and so OpenSesame will automatically fill in whatever values that the loop has stored here. So if OpenSesame is running this trial, the value under color name will be red, the value under word will be red. So it will vary according to the information given in the loop. Is that clear?
Yes, sir. Thank you.
Okay. Okay. Now we have specified, let's go back to our slide. Let's see what things we have done so far. ज़्यादा समय नहीं लूंगा. I don't want you guys to spoil your weekend. Um, so we have made the practice sequence, we have added the practice loop, we have let us assume that we have added a instruction slide. We have done all these things. The only thing that is left is there are two things that are still left. Uh, so we need to specify OpenSesame that under what condition the wrong slide should appear and under what condition the right slide should appear. So by default, OpenSesame has a correct variable already created. As soon as you create an experiment, there is a correct variable created by OpenSesame. What does correct variable basically do? It basically registers that in a trial, if somebody has pressed the correct key that we had already specified in the uh, यहाँ पर जो हमने ऑलरेडी स्पेसिफाई कर दिया है कि एक कोई किसी भी ट्रायल के लिए जो करेक्ट की होगी वो ये होगी एंड दैट विल अगेन वेरी अकॉर्डिंग टू द स्लाइड अकॉर्डिंग टू द ट्रायल टाइप. So as I told you, if it's an incongruent, if it's a red color, the correct key is Z. Even it's a blue color, the correct key is /. तो जो भी वैल्यू आएगी वो यहाँ सब्सटीट्यूट होती रहेगी ट्रायल बाय ट्रायल. Okay, so we need to specify OpenSesame that in under what condition we have to run the wrong and the right slide. So what we usually do is that you double click this space where true is written. Again, use the square brackets and write correct, and then close square brackets, and then you have to double include without any spaces is equal to 0, correct, is equal to 1. Now OpenSesame will only run the wrong and the right slide. If somebody has pressed the wrong button, it will run the wrong slide, which is this one. And if somebody has pressed the right button, it will display the right slide. Okay. Another thing that is there that is left is the logger item. Hmm? So the logger item basically, there are few tips and tricks for a logger item. Let me go back to my slide and then I'll show you the whole task. I'll run the task and we just created a very simple version of stoop task. So the logger item basically is responsible for logging everything. It's like a you could say it's a internal register. It tends to record everything trial by trial. So as soon as you open the experiment, it tells you कि कितने time में subject moved from one slide to the other, how much was the response time, whether the subject pressed the correct button or not, what is the overall accuracy, what is the trial by trial overall accuracy. Okay, so there are certain rule of thumbs. लॉगिंग में सबसे ज़्यादा दिक्कत होती है. मान लीजिए आपने टास्क बना भी दिया, इफ़ यू मैनेज टू क्रिएट अ वेरी गुड टास्क, but if you are not logging it properly, it will not help you. Ultimately, you need the data from the task. So logging the data is very important. So logging the data, you should always log everything. So अगर मैं यहाँ पर लॉगर आइटम है, यहाँ ये दिया हुआ है, इसको ड्रैग करके यहाँ ले आता हूँ. So OpenSesame has this unique facility where you can log every other variable that is created by OpenSesame, or you can ask OpenSesame to simply register things that you need for your experiment. That's it. Okay. So uh, by default, you should always leave this checkbox checked, and it will log everything. And you can then use Excel tools to identify what variables you need and what you don't need. Once you get advanced, once you get more equipped with the feature, then you can log specific variables. Always put your logger at the end of your sequence, whatever sequence is there. Always put it at the end. इसका एक रीजन है. इसका रीजन ये है कि if you log it outside the sequence, एक ट्रायल आई, सब्जेक्ट ने सही बटन दबाया, वो डेटा लॉग हो गया, उसकी एक रो बन गई एक्सेल में. नेक्स्ट ट्रायल आएगी तो वो उसी रो में ओवरराइट हो जाएगा. सो होगा ये ultimately that you will find that subject, you saw the experiment for yourself, the subject was doing it very perfectly, but when you opened the logbook you found out that the subject has zero accuracy. Why? Because at some of the trials he or she might have had missed pressing a button, एंड वो लास्ट ट्रायल थी, तो वो जो लास्ट ट्रायल का डेटा था वो सारे पुराने डेटा पे ओवरराइट हो गया और एक ही लॉग बुक में एक ही रो जनरेट होके आई. So it creates a lot of problem and it's very hard to sometimes figure out. Okay. So always put your log files at the end of the sequence. Add separate loggers. So suppose you have two blocks. You have a practice block and you have a main trial blocks. So if you have two blocks, you should always have one logger item attached to the practice sequence and the other logger to be attached at the main sequence. And if you are somehow picking what variables to log, you should carefully pick the variable names, because sometimes OpenSesame has long variables name and sometimes it is difficult to identify and we log the wrong names. So whenever you are running an experiment, triple check whether you are logging all the required variables or not. Now we have logged the data, we have created a practice sequence. Let's run the experiment for the first time. And that will basically conclude that how you can run, and then I'll take questions. Uh, let's run it in full screen. The first run might end up in a bug, so don't worry. So if you have created your experiment, you can now run with me. So it asks that where do you want to put the log file, so you can select the same folder and you can save it over here. I have already another log file of that name. Let's give it another name. Remember, I am using a presentation mode, so it might affect my timing of the experiment. Can anyone confirm that? Am I audible? Because I cannot see the screen. It's a full screen.
So you're perfectly audible.
And what about the screen?
Yes, sir. It is visible too.
What is being displayed? Welcome to Stoop Task Instructions.
No, sir. It is logging data from the presentation.
Uh-huh. Just a moment. Okay. Okay, how about now?
Yes, sir. It is visible.
Okay, it's visible. Thank you. Okay. Now let me press spacebar to proceed because at this screen we had only set key press. So if I press any key, it will take me to the next slide. I'm deliberately pressing the wrong key to, okay. So चार ट्रायल थी, चारों ट्रायल हो गई. Now let's open the log file to see what had happened. Okay, this is the log file that you get usually. So since there were only four trials, so it is showing me several important stuff. Number one, it is showing me the color. So her each row signifies a trial. So on first trial, the color was blue, the word was red, the blue. So it was a congruent trial. Accuracy was 0. I remember pressing the wrong key at that time. What was the average response time? The average response time is equal to the display time. Because I exceeded the display, because I exceeded the response window, so it is showing me the exact response time that I had set, which was 995. In the next trial, it was red, the color was red, the word was blue. I pressed it correctly. So the accuracy increased from 0 to 50 because two trials have taken place so far, and it's these two columns, they reflect values cumulatively. So cumulative accuracy ये बताते हैं हमको कि ओवरऑल अभी तक एक्यूरेसी कितनी है. तो एक ट्रायल पे मैंने एक्यूरेट रिस्पॉन्स किया है और एक पे नहीं किया है. Like here it is 0 and here I have pressed the right button, and my reaction time was 512 milliseconds. Next, it was a congruent trial, and my accuracy rose from 50, decreased from 50 to 33, because if you calculate the accuracy, you will find that I'm 33%. So out of three trials, I have correctly responded to only one trial, and my response time was 673 milliseconds. So we have successfully created a miniature version of a Stroop task using the OpenSesame. I have shared the link in which you will find the full version that I was trying to demonstrate in the session, and you will find you can use that as a staple, and you can make your own changes and you can experiment it with it. uh, But before moving, I would like to have queries if anyone has any query, or if they ran the experiment and they end up something in a bug, they can also tell me. I can quickly give them a heads up on that.
Anyone having any query, please raise your hand. Is
Anybody?
it all clear? Please react. Sir, I myself have got a query.
Please go ahead.
Sir, while doing the experiment in cognitive lab, sir, I have seen that they give a feedback of accuracy rate and reaction time. So how we can bring that here?
It's a very good question. So if uh, you can do that very easily. Uh, so let me again share my screen and I can show you. Um, okay, so in the OpenSesame, you can use this. You can display the accuracy and feedback at the very end of the experiment or every after end of every trial. It would not be wise to give accuracy responses after every trial because then it will create a bias among the participant. So the best way is to show them at the end of the experiment. So what we can do is that there is a feedback uh, item specifically for that particular thing. So we can hover our cursor over here. You can drag. You can select it after the loop sequence, and you can double click. It's very similar to a sketchpad item, and you can basically use curly brackets, write ACC, close curly brackets, and whatever the accuracy you have for that after the practice sequence, you will get here at the end, and you will get displayed on the screen. However, I do not really personally feel that that should be done in a cognitive psychology experiment because then it leaves the participants with some sort of a self doubt that if the scores are not as per their expectations, it leaves the participants a bad image of the experiment and their own self sometimes. The you should note as cognitive scientist and any psychology branch student, subject should not feel that they did not perform according to the whims of the experimenter, or it will induce negative thoughts in them. So the best way is to tell participant that there is these estimates are gross in nature and they do not correlate with your IQ. क्योंकि क्या होता है कि अगर अगर एक्सपेरिमेंट अच्छे से परफॉर्म नहीं किया किसी ने, it leaves a very bad kind of effect on their mental psyche. This is one of the things that I have noticed after years and years of experimentation. So yes, to answer your query, we can still show that and it will get popped up in the experiment after the end of the experiment.
Okay, sir.
Okay. One last thing I want to add over here is that ओपन सीसम में जो भी एक्सपेरिमेंट्स होते हैं, either you create it yourself or you can download it from the internet for free and you can run it over there. So अगर आपको कोई एक्सपेरिमेंट बनाना है, कोई स्टडी करनी है and you are short of time, you can still download that experiment and run it. बशर्ते इतना जरूर करिएगा कि you should give credit to that. These are some of the websites where you can download. So एक तो OpenSesame की खुद की वेबसाइट है where you can download their sample task and you can make changes to those sample task and you can run that. Then there is a dedicated platform called Pavlovia, which basically helps people to collect data. So people who are running studies, they can submit their task in Pavlovia, and people can go and participate in their study, and they can take data. So data बहुत rich होगा because it's a internet platform and people from all around the world will able to access your experiment. Second, you can also download that experiment and you can make changes according to your study and you can use that. Another very cool feature that I recently discovered is that there is although this website has been there for very long time, but its implication have come up after COVID, where we cannot call participants in the lab. There were situations